So, Mr. Ben, you want to take it away?
Yeah, thanks, Greg. Steal the screen share from you. So our presentation today is going to cover efficiency improvements in Power BI datasets and what we've learned. To give a little context, we recently created a series of new reports for our dental clients, and we learned the importance of dataset efficiency to keep memory usage low and to keep costs down. We'll be showing you what our reports look like, how to identify high memory utilization in DAX Studio, how to use XML endpoints to refresh individual tables, and how to debug slow-running DAX queries using the performance analyzer. So a little bit about DataDx. We provide business intelligence solutions for medical and dental practices. We use all Microsoft cloud-based products, starting with a Windows service-based application that pulls data from client source systems that is then stored in Azure Blob Storage. Then we pick up data in a Python Azure function for ETL into an Azure SQL database. And finally, we use Power BI Embedded to display front-end reports to our users. We work with accounting systems, electronic health records, and practice management systems and consolidate those different data sources to provide a comprehensive view of a practice. We're all about automation, so instead of having to rely on manually scrubbing and combining data in Excel spreadsheets, our users can view everything they need in Power BI to improve their business and ultimately provide better patient care. So just a quick introduction to who we are. I'm Ben Lawrence. I've been at DataDx for a little over a year. I've been working with healthcare data for quite some time, and I've had a chance to see firsthand how messy big data in healthcare is. I think it's really important for people like us to standardize that data and make it easily accessible. I've also been participating in the Power BI user group since I started at DataDx and actually gave a presentation last June on our anomaly detection system, and you can find that on the CSG Pro YouTube. Yeah, I'd really like to thank CSG Pro for all the help you've given us in developing our product and being there pretty much every step of the way. And yeah, I've definitely learned a lot from this user group over the past year. With that, I'd like to let Ahmed introduce himself.
Thanks, Ben. Good afternoon, everyone. Ahmed Abualsoud here, Business Analyst. I joined DataDx nearly 7 months ago now. It's been great working with this team, developing really a fantastic tool. It's been a pleasure working with them. Prior to working with DataDx, I had experience at Legacy Health and their information system department with the production engineering team. After that, worked for a local emergency department physician group as a data analyst. So I've been around healthcare data for a little bit of time and mainly focused on front-end reporting with mostly Microsoft Power BI. And speaking of front-end reporting, actually, I would like to start the session with giving you a quick overview on the dental version of our tool. Sign in here. This is the homepage, and we created this little report here to serve like in the homepage as a landing page. This is looking at the last month worth of data. So that's when the clients first sign in, are able to see the last month worth of data. There's more content here that our consulting team provides for our clients. Now, before that, we hit into the full insight package, starting with the income statement, showing practice finance, revenue, expense, net income by month and by quarter. Very good report, mimicking pretty much profit and loss, but of course we have more efficient ways to interact with the data. We also have the financial performance, analyzing 3 metrics that are production, collection, and expenses over time, by visits, by provider, by dentist, by hygienist, also comparing it with the prior year. We also have the provider productivity report, a very good one also, analyzing patients and metrics like patient per day and production per day and per patient. We also have another tab that actually does a comparison between the top 5 providers. So it helps the practice see who is most active. We also have the visit reports, analyzing procedures that happen during visits. Also, we have the visit trends, part of that, the visit report, and the visit and the volume trends as well. We also have patient report, analyzing patient demographics like age and location is very helpful, not only operationally, but also for marketing reasons. We talk about this map is very valuable. It helps the practice understand where their patients are and whatnot. We have the payer analysis. That's the practice way of understanding the relationship with the payers and understanding the performance of all the insurance that they work with. And there's a breakdown of the types of payers, and they can also drill down to see different plans and whatnot. So along with that, actually, along with this report, adjustment report also help with understanding a relationship and the performance of the payers, because this is a very important metrics to actually analyze and learn. We have also the monthly summary report, day-to-day view of the practice activity, how many patients they saw, how many visits, how much they charge, how much they collected, and whatnot. So this is also a very valuable operationally wise piece of analysis. And we have also their aging report, account receivable aging report. They analyze the outstanding balance per payers, also pair by provider and by different dates, because some of our clients report on service date, some of them report on posted date, some of them report on bill date, so some of them report on 3. So we have the ability to actually analyze the outstanding balance by the 3 different date keys. And that's pretty much a full insight, a very quick overview on the dental demo. I'd like to hand this back to Ben so you can talk about the DAX memory usage. Yeah.
So for a little background, we use Power BI embedded, and we're currently on the A2 capacity here, which limits us to 5 gigabytes of RAM. It costs us about $1,500 a month, and then the next capacity up is over twice the cost. And we found as we started accumulating more data, as we started building more reports, we started exceeding that 5 gigabyte limit. When we hit the refresh button, we would get an error. We would monitor the usage in the Azure portal and see big spikes. So we tried to figure out a way to really reduce our memory usage. And the first thing we did is we looked at our data set in DAX Studio. And what you can do in DAX Studio, you can connect to a data set, and then you can go to the Advanced tab, click View Metrics. If you go to the summary here, this will give you an estimate of the overall memory your model is using. And just to note, this is different than the size of the data set. So the size of this data set is about 19 megabytes, but the amount of memory it uses is actually around 50 megabytes. And then if you go over to the tables, this will show you a lot of useful information and show you how large your individual tables are. You can expand out tables, and it will show you how much memory each column is using too. This cardinality refers to the number of unique values in a given column. So we can see here that this transaction alternating feedback here. So this transaction alternating key column takes up about 28% of the transactions table and about 14% of our entire database or data set, which is huge. And we actually found out that we don't even need this column. This column is more used on the SQL side to ensure that a transaction row is unique, but Power BI doesn't need to know that. So we found we could just remove this column from our data set completely. So we went through, figured out all the columns we needed. Another useful trick is if you go to this DMV tab, search for measures, you can run this command, select star from MD schema measures, hit the run button, and thanks Rachel for showing me how to do this. And this will show you all of your DAX queries and all the expressions. So we pretty much determined if a column isn't used in a DAX query, we probably don't need it. So we went through, we deleted a bunch of columns, we created a new data set. And if you look at this data set, this is the same data set, except with all of the additional columns we didn't need. Go to View Metrics. It's only 30 megabytes. We dropped almost 20 megabytes off of the original data set. So in our production data set, it was a lot bigger of a decrease, actually. We went from about 1.2 gigabytes of memory usage in production to only about 400 megabytes. So it was huge. It ended up saving us a lot of memory. The next thing we did is we completely removed calculated columns. So if we look at our old data set here, this is one of the new measures we created for our dental reports. Dental codes range from 0 to 10,000, and they have a D in front of them. So every code means a different thing depending on the range. So we just created this switch statement to categorize the different code types depending on their range. And what we figured out we could do is you can actually do this exact same thing in a SQL query. So we import all of our data using table value functions. Rachel actually created this one. So instead of putting the lift on Power BI, we're doing that same, we're creating that column in SQL Server instead with a case statement, which is very similar to the DAX calculated column. So instead of Power BI having to use its memory to generate that, we're putting that load on SQL Server. So both of those things ended up saving us a lot of memory. We stopped seeing those timeouts, but we noticed that we were still hitting about 3.5 to 4 gigs of memory usage, which is still a lot. And I think that's because it takes a lot of memory to pull in that data from SQL Server. Power Query has to clean it up a little bit, and then it does its compression, which will ultimately bring it down to like 400 to 500 megabytes of memory. But we're still seeing some pretty high spikes. And those happened in our workspace when we were clicking on the refresh button for a data set. So we clicked the refresh button, and then we went in the Azure portal, which I'll be showing in a little bit, and it would show us the spikes. And then another helpful thing you can do is you can go to the settings here, and you can click on the refresh history. This will tell you how long a refresh took. But in the Azure portal, it'll actually show you how much memory is being used. If you're looking for more refresh metrics, I would recommend downloading the Premium Capacity app, which is super helpful and gives you a lot of averages on all of your data sets. And then the admin portal also shows some pretty good information too. So what we wanted to do was figure out a way to reduce how much memory was being used on refresh. And our idea was to prevent parallel loading of individual tables. So many of you are probably aware in Power BI Desktop, if you go to the options, there's a button to disable parallel loading. But unfortunately, that only works in Power BI Desktop. Once you publish it to Power BI Service, hit the refresh button, all the tables are going to load in parallel, and we're going to see those memory spikes. So luckily, Power BI released a new feature just this January to the public called XML Endpoints. And XML Endpoints are really cool. They allow you to access the analysis services engine in the Power BI service. You can do a lot of really cool things with the XML endpoint, but we really want to focus on the data set refreshes. So yeah, just an FYI, this is only available in the Premium Capacity or Power BI Embedded, but I think they're planning on making it available to everyone. So to enable XML endpoints, you have to go in your admin portal, and then you have to enable read-write access. And then what you can do is you can go over here. Once that's enabled, click on your settings, go to Premium, copy this workspace connection. So then from there, you can go into SQL Server Management Studio, go to Connect to Analysis Services, and then copy or paste in that workspace connection. So once we connect to a workspace, it's going to open up our entire workspace and list out all of our data sets. From there, we can right click, we can look at the properties. So this will show us things like the last refresh on the data set, the estimated size again. And we found this is pretty much like having DAX Studio on your actual Power BI service. It's really cool. You can do a lot of really cool things. For example, you can refresh an individual table with this XML query command. We can execute this. And this is going to refresh just one table at a time. This only took 3 seconds to refresh. And this is really important to us because this table in particular, user permissions, when we add a new user, a new row is added for that user, and then row level security controls what that user can see. So before, when we added a new user, we either had to refresh the entire data set, which took 5 to 10 minutes, or we'd have to download the data set, refresh this one table, and then republish it. But now with XML endpoints, we can just refresh this one table. And then to take it one step further, we wanted to automate refreshing all of our tables in order without that parallel loading. So to do that, you can actually create a PowerShell script. And just for reference, everything we're showing regarding PowerShell and automating XML endpoints can be found in this really great article from Brett Powell. This has everything you need if you're looking to set up automated refresh. You can even set up runbook automation notebooks to set a schedule on these refreshes. So it's really good stuff, and I can share this link later if anyone's interested. So if I kick off this script, it works the same way as that command I just showed you. We connect to our workspace, specify the data set we want to refresh, and then we have a list of all the tables we want to refresh. So down here you can see it's refreshing each table one by one. And this made a pretty big impact in our production data. So we looked in the Azure Monitor, and so the first thing we did is we completely reset the PBI embedded capacity to make sure everything was fresh, no memory was being used in the capacity. And then we kicked off our PowerShell script, and we started refreshing each table one by one. And we can see the max memory usage here was 2.5 gigabytes. We then reset the capacity again, and then hit the refresh button in Power BI Service. And that loaded everything in parallel, and we hit a spike of 3.2 gigabytes. So pretty big difference, and we think this is going to save us a lot of time, save us a lot of space. And we're still trying to tackle one more thing. Well, the problem we're having now is we have to refresh millions and millions of rows worth of data, especially in our transactions table every day. And we're trying to find a way to only refresh new data or updated data. And you might say, that's what incremental refresh is for. So if you're not familiar with incremental refresh, it's a really cool feature that's pretty new. It pretty much allows you to use a date parameter. In this example, Microsoft has, they're using order date, and they're specifying they only want to display order dates between a given time period. And then after that, only refresh data with an order date in the last 10 days. So every day it's only going to refresh data in the last 10 days, or every 10 days, or however often you refresh your data set. And this is really cool. There is one major downside. Once you publish an incremental refresh data set, you can't download it back from Power BI Service, which is a pretty huge limitation. And our problem is incremental refresh doesn't work with updated data. It only works with new data. So if, for example, if we have a transaction that was updated, maybe an insurance carrier changed on a particular transaction, we picked it up in our new SQL load, incremental refresh would think that's a duplicate because it has the same key. So we would get an error, a one-to-many error in Power BI, and incremental refresh just doesn't work. So what we did is we tried to create our own version of incremental refresh using XML endpoints. And to show you that, what we did here is we had this example, transactions all. This would be an example of pulling our entire transactions table, pretty much a select all on our transactions table. We might limit it to like 2018 forward or something to save a little space, but essentially it pulls all of our transactions data. The new idea is we would have a transactions historical table that we don't touch. This would pull data, for example, everything from March 1st and before, historically. And we wouldn't touch this table because incremental or XML endpoints exist. We wouldn't have to refresh this table if we didn't want to. And we'd have another transactions rolling table that would refresh every day, and it would have everything after March 1st. So the idea here is we would have that historical table. We would append the historical table onto the rolling table. And then we would remove duplicates. And since we're appending the old data onto the new data, it would inherently pick up the most recent duplicate, and we would keep the more recent updated data. But unfortunately, we found that this was actually slower than pulling all of the data, and it used more memory. And that's probably just because Power BI had to work, or Power Query had to work with all of this data, appending it and dropping the duplicates. So unfortunately, that solution didn't work for us. And actually, we were able to test that with another really cool feature you can do with XML endpoints, and that's connecting SQL Server Profiler to your Power BI service. So to demonstrate that, you can open SQL Server Profiler. You can connect back to Analysis Services, and this step's really important. You have to click Options, and you have to specify which data set you're connecting to. Log in here. Sorry, Greg, have there been any questions yet?
Nothing I'm seeing as of yet.
Okay. So yeah, so we can specify a data set we want to connect to, hit connect, and then you want to go to the event selection over here. This gives you a lot of different commands. And if you want to learn, if you want to learn how to use SQL Server Profiler, I highly recommend Chris Webb's blog. He has a lot of good tutorials. He has a really good video where he talks about performance tuning and data sets and how to use SQL Server Profiler. I can also share these links later too. So anyways, Chris recommends checking two different events, command begin and end, and then also progress reports begin and end. Another thing that's really helpful too if you want to test DAX queries is you can check query events, and query end will tell you how long a DAX query takes to run. But for refreshes, these 4 events are the most important. So we click run. This will take just a minute to load. But in the meantime, I can show another really cool feature, and that's being able to execute DAX queries on your Power BI service using XML endpoints. So if you want to check something like just the count of a table, we can execute that DAX. Hold on, I lost connection here. There we go. So here's the count of the table. You can pretty much do anything you can do in DAX Studio here. I think this is really important, especially if you are using incremental refresh. Since you can't download a data set back, you can do stuff like check the data after a certain date. Check all that data. You can even copy all this and paste it into Excel to work with it. And then to really highlight the example I showed earlier about the updated data. So the transactions historical data set could potentially contain something like a payer on this transaction has an ID of 75. And then a couple months later, they decided to change the payer or the insurance carrier on that transaction, and they changed it to 1111. So just wanted to show this to highlight that this is really why incremental refresh won't work, because it doesn't like updated data like this. Okay, we go back here. This is loaded in now. We can go back, execute one of these refresh commands again. I'll do it on that transactions rolling query I just showed you. We go back to the profiler. It starts showing us pretty much everything that's going on behind in the query. If we go to this text data, this gives a lot of detailed information. There's a duration column that shows you how long each step is taking. And yeah, this is really helpful. At the end, it's going to give us a command end that summarizes everything and tells us how long everything's taking. So this is how we were able to test and really determine that our own custom incremental refresh isn't going to work because it actually was taking a lot longer and using more memory. Yeah, and if you want to work with this data, you can export this data to XML and then load it back in. But if you want to work with it in Power BI or export it to a CSV, it's a little more difficult. You can go to Save As, save the trace table. Right now I have a local database here, so I'm going to point it to my local database. Name the table. And we can go back to SSMS. Refresh here. So that trace that I just created is now here as a table. And it makes it a lot easier to do it this way because then you can just save these results as a CSV. And then you can actually work with this data in Power BI and create some metrics around how long your refreshes are taking or how long your DAX queries are taking. So this is kind of the last problem that we're trying to solve. We're hoping that Power BI increases the capability of incremental refresh in the future. And we're kind of wondering if anyone has dealt with similar issues and if you have any solutions to this last problem we have. So yeah, I'll let Ahmed close it out with some tips on the performance analyzer.
Yeah, and that's a good point, Ben. I would love if anybody in the chat, is kind of going through the same type of issues or experiences, and once we hit the Q&A piece, we can address people's specific experiences.
Yeah, definitely.
Thanks, Ben. So it's really great witnessing everything Ben and the team been doing in terms of optimizing our Power BI data sets and making sure our refreshes are inducing any spikes in our memory usage. But we also realize that optimizing performance takes place at different architectural layers. Not only data source we need to focus on, we need to focus at the data model, for example, but also we need to make sure that we are paying attention to our live report and our visuals and our DAX and seeing the performance and making sure that it's not causing any memory usage or exceeding any memory usage. Now, we all know that poor DAX measures will lead eventually to slow reports, and also poorly designed visuals will eventually lead to slow reports. But funny enough and weirdly enough, poorly optimized visuals will also lead to slow reports, and that's something we ran into as we grow and large in size. We got all these dental clients get on board in our data sets, and we use Power BI Service Live Connection feature. We have one shared data sets, or all our Live Connect report are connected to that shared data set. So it grew very dramatically in size. So all these little optimization we set in place for specific visuals have become actually a problem. And we have an example of that in the pair analysis report. I'm gonna have to just pretty quick open up the report. We had set a filter on one of the matrix visuals we use. We set a filter to exclude any blanks, any zeros. Just a way of making sure the end user, the client, is focused on the glass half full and getting that value that they need. And sometimes blanks could, lead to making the visual a bit not friendly or not informative as it should be. So the problems here was that eventually, after we really grew large, that filtering out those zeros have caused exceeding the memory usage. That's that spike that Ben was talking about earlier. Just because we're trying to exclude zeros out of this matrix, it actually hit 5 gigabyte. It hits the limit, and it times out, and it's affecting the report. And every visual sometimes waits for other visual, so it's affecting the entire report problem. And I would like actually to reproduce that as showing this problem here. So if you came over here to set that filter on there. Also, hence that this is a demo data set. This is not as large as our production data set, and so the numbers or the time that it's taken doesn't reflect the actual times that we've been seeing with the production data. So yeah, it keeps rendering until it times out. I don't want it to time out, so I'm just going to cancel this. And so this problem didn't only happen here. We ran into it in other reports. In our visit report here, one of the tabs, the volume trends, we have another matrix here that is looking at different procedure types and metrics like visits, patient number, patient production per patient. So the same problem happened here. Didn't time out. However, it was slow, very slow, noticeable, not friendly. We don't want it to happen. So we decided to start using the performance analyzer to just try to understand what's going on and the time it's taken. Again, this is not as large as our production data set, so it might not reflect the times that we see there. So if you start interacting with the report and look at the last 13 months of data, we can definitely see that this is definitely one of the highest. The volume trend matrix is one of the highest in time. Of course, again, in our production data sets, actually, the first time we noticed that problem, it was taking 9 seconds to generate, which is really a long time. And we know that RLS will be set and that will help, but also it was not as we would like it, as quick as we would like it to be. So one thing is very interesting about Performance Analyzer, that it lets you to copy the DAX query that actually ran to display the visual. So, a way to actually try out a couple of things and try out a few things to make sure that to improve the performance. So we took it to DAX Studio here. Let's make sure the right data set. And we used the server timing trace to be able to get that information that we could use. Oh, man. Cool. Okay. Turn on the server timing trace. It's a very interesting feature here. DAX Studio has not only we are able to capture the duration that it took for that DAX to happen, but we also, the server timing trace gives a lot of more information that we are still learning. It's very interesting. First that's what we've been looking at the total duration of the query, but also there are many interesting information here, like the storage engine queries, which is the number of queries sent to the storage engine while processing this query, and also here what SQL-like queries are called actually XML SQL, which is a textual representation of what the formula engine sent to the storage engine. Something we're still learning. However, looking at this query, we tried to kind of test out a few things, like taking out certain filters. We learned that actually first thing here, first couple variables that it defines is actually the filters that are applied on any slicers here in the report. Also, along with that, the first thing it defines the filters that are applied on those two sections, the filters on this page and the filters on all pages. So that's what we first see here, and then it summarized columns, which is kind of the select statement to bring in the 2 dimension that we report on all these different metrics. And then in the filter function, it adds any filter that we set on the visual itself. So, it's a good way to start testing out this query, taking out certain filters and see if that's improving performance. We did that to make sure, to see if we can keep the 0 filter on, because it's been helping us a lot. Like I say, excluding values that are actually might be distracting. So we kept trying out to take in certain filters out, like for example, take out the location blank filter, taken out from the summarize columns functions here. Run it again and see if that's improving performance. And it definitely, when we did that in the production data set, we went down from, we tried that and taken out the location filter, and it went down like maybe 80 milliseconds, but we started seeing differences. We started testing out a couple of scenarios and see if we can keep that 0 filters. It was hard. It was obviously that was what's causing the performance problem. Well, we came up with a different solution that is working with us so far, but we're all about efficiency, so we're going to keep working on it and see if we can improve it. We came up with this measure that is actually referring to the transaction table and counting out the rows to see if if a certain item, like for example, if we go back to the Live Connect report, it goes back to the transaction table, and it just count the rows for each of those items, or each of those dimensions, and see if, for example, this procedure table, how many rows how many rows, how many transactions were taking place for that procedure. So if in case that procedure was not performed, then no records, we were hoping that this would actually exclude them, and actually it worked for us, and it was much quicker in terms of performance. And so far so good. We're still working on it. We're still trying to figure out other ways. So if anybody had any suggestion, like somebody that ran into a problem like that, excluding zeros or SAN filters that actually eventually led to slow reports, even though we hope that SAN filters limits the amount of data, that means that we hope that the visual will display better. But like I said, poorly optimized visuals usually also lead to slow reports, and that what happened here. And that little solution helped us kind of tackle this problem, but we're going to keep working on it. We're going to keep trying to find out other solutions. So with that, actually, I would like to end this with kind of another review on the dental version of the tool. I know we talked about it pretty briefly when at the start of this session, but I'd like to actually highlight a couple of things. Highlight the differences between our dental report and our medical reports. Talk about the things that the process and how we managed to create that. So one of the things that we made sure that we keep is our design elements, our look and feel, our layout. Didn't change a lot between the medical and dental reports. However, most of the time we're put into adjusting re-engineering our DAX measure to make sure that we are responding to the business logic that our dental clients have, because their data is a bit different, and the way they capture measures like production and patients and collection is a bit different. So sometimes we have to re-engineer some of our DAX measure, and we had to create also new measures to capture those values, and that's mostly where the time was put, but also that led to changes to some of our reports, like the provider productivity. Now, one thing about our medical clients are they are RVU based. RVU being relative value unit. It's kind of the payment system that the healthcare practices use. Now, our medical are RVU based, so that's why it's a very important metric, and we report a lot on that in the medical version of the tool. However, our dental clients are not RVU based, so that's one of the things that that's one of the big things you notice, that how the differences between our medical and dental clinics. Another change was in the financial performance. This is a very interesting report, actually. We talked about it, analyzing production, collection, and expenses over time. We also had two new visuals here that are looking at analyzing these three measures by dentist and by hygienist. That's another change. Also, we introduced a couple new reports, but one of the highlight, let's say, is the volume trend. We created this based on actually feedback from one of our clients who were very interested in analyzing their restorative visit, which are anything that refers to the dental procedures that are aimed to repair a damaged or missing tooth, talking about implant filling, crowns, and whatnot. So one of our clients who used to refer their patients to another clinic for these specific procedures, due to COVID and the closures and being unsafe to keep sending patients from one place to another, they wanted to understand if it's worth it to bring someone in-house to perform these procedures, to actually help the patients in the clinic, and not have to refer them to a clinic that isn't open yet, and there's the exposure again to more people, exposure to another office. So due to safety, it could be a great solution to see if they can bring in someone in-house. So we started just analyzing restorative visit, then this expanded to look at all the different categories, all the different procedure types, whether a diagnostic, restorative, preventative, hygiene. And actually, that client mentioned that it almost taken 40 hours to generate this piece of analysis right here. And I'm not saying it's easy to do it in Power BI. There's so much data engineering that goes placed into making sure the data is clean enough to simply create that visual. But there's also optimizing it, as we were talking. You tried to optimize the visual. So it isn't easy, but it is way more efficient. And this is what this whole thing about, this meeting is about, and what we do is about. It's all about making sure everything is more efficient, making sure that they are more efficient. If we are more efficient, they are more efficient. The better, the more efficient they are, the better care we get, the more efficient health we have. So this is very important, and it's not enough to have some solution working. We need to always keep improving it, always making sure that if there's a chance to improve and make it more efficient, we should, because our user base are very important, and what they do is very important to us, to everybody, and a threat to their survival is a threat to the public health. And for that, we take it very seriously, what we do, very, very seriously. So thank you all for listening, and if anybody have any question, fire them up.
So we did get one question. Is it better to filter in Power Query versus the visuals and the report, or write DAX that does the filtering?
Sorry, Greg, can you repeat that question?
Yeah, is it better for performance to filter data from in Power Query versus the visuals in the report, or write DAX that does the filtering?
We actually kind of still experimenting on that. So far, we've been noticing that filtering on the visual was kind of our best way to go. But with that example, now we are reevaluating that, and we're looking into like other ways, like using a DAX measure, like we once showed. So yeah, it's something we're still navigating.
Okay. Let's see. Do you see Premium Gen 2 helping with the memory on refreshes?
What do you think, Ben?
We haven't looked into Gen 2 that much, but we do want to test it out for sure.
Yeah, I'm really excited for Gen 2 and some of the auto scaling features.
Oh yeah, I did want to mention that we're working on creating a script to autoscale right now. If we go back to the capacity prices, so embedded is charged by hour. So our cloud architect, Joe, is working on writing a PowerShell script that will automatically scale during or outside of business hours. We'll scale back down to A1, and we're trying to figure out a way to automate that script even further. So depending on the load of our embedded capacity and how much memory is currently being used, we can scale up and down automatically. So I know that that's a feature with Gen 2, but it's not enabled in embedded yet. So for embedded, we do have to go through a couple extra steps to create a feature like that ourselves, for now, at least.
Got it. Of course, the answer is it depends. It's always it depends, no matter what. Yeah.
Yeah, and I think next month Joe is actually giving a presentation at the user group about this too.
Yes, in March, right?
Yeah.
This month. Yeah.
Yeah.
Any other questions, or again, open forum for any of the audience that's been using DAX Studio or has been working through just kind of performance tuning in your own reports. If you have any questions or experiences you want to share, drop it in the chat. If you do want to even come off mute to kind of share, to the rest of the group, feel free. We have at least 8 more minutes until Brian's on. If nobody has any questions, of course, we can get started sooner, but we'd love to hear from the community. If anybody wants to talk about their experience as well.
Yeah, I'd say it looks to me like you're doing all the right things. I assume you guys look at the Italians SQL BI site articles for some tips on debugging and performance improvements. Yeah, that's where I've had a lot too.
Has anybody been using the DAX Do tool that had been released recently?
Yeah. I played with it a little bit. It's kind of nice. You can, you know,
So
just
that
because there's a
will-
database when you're just playing with some DAX code, you can just throw it in there real quick.
Yeah, and I know it's built off AdventureWorks now, and their hope is to be able to allow, like, you could put your own demo data set as the back end at some point.
Okay, I hadn't heard that.
Mm-hmm. They're definitely making strides, those SQL BI guys. Any other questions or comments from anybody in the room? We've got 60 people on, so again, thanks everybody for making it. You know, just a comment to make. You know, I did say this earlier. You know, I've just been so impressed with the meteoric rise that, you know, those at DataDx have been on, and just how willing you guys are to share your knowledge and share with the community. Truly appreciate, you know, you guys being so close to us and everybody in the Pacific Northwest. It's great seeing, you know, a company that's just right here in our backyard that has fully embraced Power BI and the full Power BI architecture, and just kind of be along in the ride with us. I mean, here we are with a product that changes every month, and that you guys have to react to, I'm sure, every month as well. Maybe if you want to speak to just kind of the experience you guys have had, you know, choosing this as your platform, as we wait for some questions.
Yeah, definitely. I mean, we have learned so much from CSG and this user group, all the members of this user group. So yeah, we love sharing our knowledge and bringing it back to the user group. Yeah, this has always kind of been our home. Like I started out in this user group and learned everything I know about Power BI from you guys. So you know, just make
Love it. Do you guys have any like exciting or capabilities you're thinking about releasing into the product anytime soon, or I don't know, any insider stuff you guys can share before we make the transition? If not, no worries. Not here to put any pressure.
yeah, we're still mainly trying to figure out that big problem. Ahmed, think of anything, or John, you're on the line.
I don't think I'm allowed to say anything. We're always making new reports though and new features, so check in with us in about 6 months. Maybe we'll be able to share a little more.
Awesome. Well then, thanks a lot, you guys, for presenting. Really appreciate it. How about we give them a round of applause? If you don't mind coming off mute, let's give them a round of applause to thank you for presenting.